Okay, in this video we're going to talk about mechanical advantage and how to calculate mechanical advantage. So there will be several problems that you'll be working along with me. When a machine, any type of simple machine, when it allows you to move something with less effort, force, than the weight you're trying to lift, then we say it multiplies the amount of force that you actually push with. So it makes work easier for you to do. It gives you a measure of how much the help the machine is being in helping you do that work. It's how many times that machine multiplies your effort. That's mechanical advantage. How many times the machine will multiply your effort force. So one formula we can use for mechanical advantage is it's the resistance force divided by the effort force. Or here's the equation. Fr is your resistance force, Fe is your effort force. So using the information in the data table, calculate the mechanical advantage of a simple machine in each trial. The mechanical advantage is given. Calculate the missing force. So to find mechanical advantage, when our resistance force is 5 newtons, so mechanical advantage equals a resistance force of 5 newtons divided by an effort force of 5 newtons. That gives us a mechanical advantage of 1, meaning it didn't really help us multiply or make the work any easier. I'm having to put in the same amount of force as I'm getting out. All right, and number 2, let's say the resistance force is 3 newtons, but the effort force is 1.5. So in that case, I'd have a resistance of 3, an effort of 1.5. So when I take 3 and divide it by 1.5, that would give me 2, meaning that the machine made it twice as easy to do that work. Okay, on simple machine number 3, I already have the mechanical advantage, so I'm going to put in a 6 for that. And that's going to equal a resistance force of 3, and then I have to find my effort force. Okay, so again, I'm just going to solve for that variable in the bottom. So I want to get it out of the bottom first, so I'm going to multiply both sides by Fe. So that's going to be Fe times 6 equals 3. Then I'm going to divide both sides by 6. Fe equals 0.5 newtons. So to have a mechanical advantage of 6, if I get out 3 newtons of force, I have to put in 0.5 newtons of force. And the last one, to do the last one, I'm going to, again, do the same thing. I'm just going to plug into my formula there, and I'm going to solve for my variable. So this time I know that my mechanical advantage is 0.5. I am looking for my resistance force, and I know my effort force is 4 newtons. So I'm going to multiply both sides by 0.4, or I'm sorry, by 4.0. And then my resistance force would be equal to 2. Because 4 times 0.5 is 2. So my resistance is 2, or my effort force is 4. So with that being a mechanical advantage less than 1, that means I actually have to put in more effort than I'm going to be getting out. Okay? All right, let's look at mechanical advantage in a different way. In many cases, it's hard to measure effort force or resistance force. It's very difficult to measure those things. So we may use it in terms of work. Remember that work in is the effort force times the effort distance, and work out is the resistance force times the resistance distance. So ideal mechanical advantage in an ideal machine, the work in should equal the work out. So force in, effort force times distance, effort distance should equal resistance force times resistance distance. So what we can do with that then is we can divide both sides by the effort force and the resistance distance. and get this equality. Or we can also say that mechanical advantage is equal to our effort distance divided by our resistance distance. So here's another equation that we can use to find mechanical advantage. So we're going to do the same thing again, but this time in this data table we have distances rather than forces. So our mechanical advantage is equal to effort distance divided by resistance distance. So 3 meters divided by 0.25 meters, not newtons anymore. So that is going to be 12, a mechanical advantage of 12. Okay, on the next one, I have a effort distance of 4 and a resistance distance of 8. So mechanical advantage would be 4 divided by 8, which is 0.5. The third one, I have to plug and chug. So let me erase this, give myself some room here. Alright, so what I'm going to do is I'm going to put in my mechanical advantage, which I'm told in the problem is 1. My effort distance, I'm told, is 6, and so I'm looking for my distance, my resistance distance. I'm going to multiply both sides by the distance. So my resistance distance is equal to 6. And the last one, I have to find my effort distance. I know my mechanical advantage, I know my resistance distance, and now I have to find my effort distance. So I'm going to multiply both sides by 5. So my effort distance is equal to 5 times 5, which is 25 meters. So to have a mechanical advantage of 5 and a resistance distance of 5 meters, I have to have an effort distance of 25 meters. Okay, either method you should come out with the same mechanical advantage no matter which one you use. It's always going to be less than ideal. If the conditions are not ideal, that means that the resistance force divided by the resistance effort will give an actual mechanical advantage, but the effort distance divided by the resistance distance will give you a theoretical mechanical advantage. Okay, so now we're going to go through some of these questions, and I will be picking and choosing ones for you to do on your own, and then we'll work some of them together. So number 1, if a machine has a mechanical advantage greater than 1, it helps you by doing which of these 3 things? Reducing the amount of force you apply, makes it easier to push or pull. Reducing the amount of distance you need to push or pull. Or C, changes the direction of your force. If your mechanical advantage is greater than 1, then that means that reduces the amount of force that you have to apply to move that object. Because remember that our equation is resistance force divided by effort force. So if this number is going to be greater than 1, then this has to be your smaller number. So you are going to reduce the amount of force you have to apply. If a machine has a mechanical advantage of 1, what can it do for you? Change the direction of the force. Sometimes if you change the direction that you have to apply the force in, it makes that work easier to do. Okay, number 3, if a mechanical advantage, or if a machine has a mechanical advantage of less than 1, what kind of help might it give you? Reduce the amount of force you apply, reduce the distance you need to pull or push that force, or change the direction of your force. It will reduce the distance that you have to pull or push. So it would make it quote-unquote easier in that you don't have to apply that force for as long of a distance. But you're actually going to have to put in more force than you would if you used a machine with a mechanical advantage greater than 1. Machine has a mechanical advantage of more than 1. How does the effort distance compare to the resistance distance? The effort distance is going to be greater. You're going to have to apply that force. You might have to apply a lower force, but you're going to have to apply it over a greater distance. So the effort distance will be greater than the resistance distance. And just remember that formula. The mechanical advantage, effort distance is divided by resistance distance. So to get this number to be greater than 1, this number is going to have to be greater than this number. So dE must be greater than dR if mechanical advantage is greater than 1. Okay, let's look at some of the other problems here. Using the formulas together, we're going to answer these questions. The formulas for MA can be used together to find missing information. Calculate the answers for the following questions. Now, you have to remember in this that you have 2 equations. And we may wind up having to put the 2 equations together to solve for different variables. So if we put the 2 together, FR over FE equals DE over DR. Oh, that is not very clear. Since they're both mechanical advantage, they should both be equal. Regardless of which way we do it, we'll get the same mechanical advantage. So we can set those 2 equations equal to each other and help us to find some of the variables we might be looking for. If you choose a pulley system with a mechanical advantage of 4 to lift a crate that weighs 750 newtons and you pull 12 meters of rope, calculate your effort force and the distance the crate was lifted. So we're actually looking for 2 variables here, which means we're going to have to do these 2 equations separately. We know our mechanical advantage is 4, so it's going to be 4 equals. The crate weighs 750 newtons. That is our resistance force. Whatever the object weighs, that's your resistance, and so that's what we're trying to lift, divided by your effort force. Well, that's one of the things we're looking for, FE. So we're just going to solve for FE. So this is going to be, I'm going to have to do this twice. Divide both sides by 4. So FE equals 1, 3, 8, approximately 187 or 188 newtons would be our effort resistance. That's how much force we would have effort resistance. Sorry, there's no such thing as effort resistance. That's our effort force that we have to put in. Okay, I'm going to erase that and then do the other question that it asked for, which was the resistance distance. So I'm going to need to erase all of this and start over again. All right, so same different equation, looking for MA equals DE over DR, and this time we're looking for DR, the resistance force. So my MA is still 4. My effort distance is 12 meters because it says I pulled 12 meters of rope, so my effort distance is 12 meters. and I'm looking for dr. So again, I'm going to multiply both sides by dr. Then I am going to divide both sides by 4, so dr equals 3. Because I divide 3 meters, sorry, because I have to divide both sides by 4. If you use another pulley system to raise a crate above your head, you pulled 30 meters of rope to raise the crate 7.5 meters. How much force did you need to apply if the crate weighed 700 newtons? Now this is where I can use the double equation, because I know my resistance force, that's Fr. I know my effort distance, dE. I know my resistance distance, dr. And I'm looking for my effort force. Okay, so I would put into this equation right here, effort resistance over effort force equals effort distance over resistance distance. 700 newtons divided by Fe equals 30 meters divided by 7.5 meters. Okay, and then just the easy way to figure this out is I'm going to cross multiply and divide, and I'm not going to work out each step, I just don't have room, but I will talk you through it while doing it on my calculator. So I would take 700 times 7.5, which gives me 5,250, and then I would divide that by 30, because it's cross multiply and divide, and that gives me an effort force of 175 newtons. So I have to put in 175 newtons, pull the rope down 30 meters to get it to pull a 700 Newton force object 7.5 meters off the floor. If you use a lever to try and pry a 1,500 Newton stump from the ground using a force of only 250 newtons, how far do you have to push if the stump is raised 0.25 meters? So again, I'm going to do the same thing again. I have an effort, a resistance force, I have an effort force, I have a resistance distance, and all I'm looking for is my effort distance. So I'm going to plug into this equation again. That's going to be 1,500 divided by 250 equals 0.25. Oops, put that in the wrong place. .25 is my resistance distance. So again, I'm going to cross multiply and divide. So if I talk you through it here, it's going to be 1,500 times 0.25 and then divide that by 250 is 1.5. It means I have to push down the lever 1.5 meters in order to get the stump to raise 0.25 meters. Okay. And that's it. So that's it for calculating mechanical advantage. Each individual machine can have its own mechanical advantage, its own formula for mechanical advantage. But the two basic formulas are resistance force over effort force and effort distance divided by resistance distance. Okay. All right, that's it. I will have another worksheet to send home to post on Google Classroom that you will do for homework, since we have worked out each of these on our own. So this gives you just a little extra practice, and then I'll have another sheet on there for you to work on for homework. And if you have any questions, just let me know.